Math is a pretty important subject.
Hi class, it's Mr. Robinson. Glad you clicked on this video. You gotta love math. Hey, it's Mr. Robinson's look at trig, the infamous trigonometry.
Sakatoa, baby!
And my world is love.
Hi class, welcome to trig lesson number 5. Now we're going to be determining angles and sides of right triangles. We're going to be putting lesson 3 and lesson 4 together. We learned how to find the length of a side. We've learned how to find an angle. Now we combine both procedures to solve right triangles. And when I talk about solving a right triangle, that just means that we can find every single side and every single angle. So I want you to try class exercise number 1. I want you to give it a go and find x, whether it's an angle or a side. Go for it. Okay, we're back. Let's take a look at A. Well, x is right here. It's an angle that we're finding out. We have our opposite and we have our adjacent. And so if we have the opposite and we have the adjacent, we want to use TOA, okay, which is the tan of a certain angle equals the opposite over the adjacent. So tan x degrees equals 12.7 over 5.2. We throw that in a calculator and that would give us x degrees equals 68 degrees. I hope you got that. All right, we also, for B, want to use our tan. We want to use our TOA, okay? In this case, we've got this side here that we're trying to figure out. It is the opposite, and we have our adjacent. We still haven't touched this one. We know it's the hypotenuse because it's the one that's right across from the right angle. We've got the tan of 24 degrees equals x over 68. All right, so in this case, x equals 68 times the tan of 24 degrees. How did we get that? Well, in this case, we can do our cross multiplication. So x equals the tan of 24 degrees times 68. A simple cross multiplication. All right, we throw that into a calculator and it equals 30. Okay, so this is going to be 30. We don't know the units, but x equals 30. Letter C, we're trying to find the hypotenuse and we have the opposite. Well, that is a perfect sine of a certain angle is equal to the opposite over the hypotenuse, the saw in SOHCAHTOA. All right, so in this case, the sine of 69 degrees equals 126 over x, okay? And so x would equal 126 over the sine of 69 degrees. All right, and that's just taking this and manipulating it around. So that would equal 135. For this last one here, I'm going to whip out my calculator. In this case, we've got the hypotenuse and we have the adjacent. So if we have the A, then we're going to do a ka in the SOHCAHTOA rhyme. So we've got the cosine of x degrees equals, and this is 4.0 over the hypotenuse, which is 7.2. So I'll just show you what we do here on a calculator. Just to remind you, it's 4 divided by 7.2, and that equals something. And then we're going to put our inverse down and cosine it. And that equals 56.25. We're going to write that in. X degrees equals 56 degrees. So right here is 56 degrees. Great. Now, the important thing about learning some of these techniques is to be able to use them in actual problems. So we have a word problem here where we have a telephone pole. It's right here, and it is 11 meters high, and it's supported by this wire that's hooked into the ground, and that's 13 meters long, and it's fixed from the ground to the top of the pole. We need to calculate to the nearest degree the angle between the wire and the ground. Now I wish that you would draw a picture, then try to calculate A, and then take a look at B, and using Pythagoras or trigonometry, try to find out the distance to the nearest 0.1 meter between the point where the wire is fixed to the ground and the foot of the pole. Basically, this letter D right here. Go for it. Great. Well, let's start off with finding out this x degrees here. Well, in this case, we're going to use the sine. Now, why would we use the sine of x degrees? Well, let's take a look at what we have. We have our opposite. We have our hypotenuse. Okay, so S equals O over H. Great, so sine x degrees equals the opposite, which is the 11, over 13. We've got our calculator here. We put 11 divided by 13 in. That gives us 0.846 inverse, and then it's sine, and that gives us 57.79 degrees. We're going to call that 58. So in this case, x degrees equals 58 degrees. And so we would write the answer right here. Angle between wire and ground equals 58 degrees. It's always good to put a sentence answer in. Now we've got Pythagoras, we've got trig. We can figure out D both ways. Well, let's try Pythagoras. Well, we know that a squared plus b squared equals c squared. And c squared, this is always that hypotenuse here. So let's see, do we have the hypotenuse? Yeah, we do. So we do have c squared. So we're going to put 13 squared in there. And then it's going to be a squared plus this 11 squared. Okay, so what do we do here? Well, in this case, we are going to isolate a squared. So a squared equals, and we're going to take away this 11 squared. So a squared equals 13 squared, take away 11 squared. All right. Now, 13 squared is, just throw that into the calculator, 13, you can go times 13 like this, and that equals 169 minus 11 squared. We could do it this way, type in 11, hit the squared sign, that equals 121. All right, 169 take away 121 equals 48. So a squared equals 48. We root both sides. The square root of that, we could throw that into the calculator as well. So we've got 48, and we need to find the square root here, and that gives us 6.92. All right, we're going to write it as equaling 6.9. We can throw that in here. It is 6.9 meters. Now, can we use trig to do the same thing? Is it faster? Is it slower? Does it take more time? Well, in this case, we've got to take a look at what we have. We have something that we could use the cosine for. Okay, so the cosine of 58 degrees, okay, and that is our 58 right here. Okay, in this case, it would equal whatever this is, D over 13. All right, and that is the adjacent over the hypotenuse. So let's throw that in. D equals the 13 cos 58 degrees. Okay, now how did we do that? Well, we know that this times this equals that. If this is cos 58 degrees, and this is D over 13. And we want to isolate this right here. Okay, we multiply both sides by 13. Okay, that cancels these out, and then we're left with our D equals 13 times cos 58. That's what I wrote here. Okay, we throw that into our calculator. 58 degrees, the cosine of that, times 13, and that gives us 6.888. We're going to say that D equals 6.9. Hey, who knew? It's the same. Great. All right, now we've done this, but we're going to make it official. We're going to solve two more right triangles. Okay, and when you solve a right triangle, it just says that you get all the pieces of the puzzle. You get every single side and you get every single angle. Okay, so I want you to work to get every single side and every single angle for class exercise 3. Go for it now. Okay, we're back. Well, the first thing is you got to figure out what you have. What we have are hypotenuse. We can see that right here. And I see a 37 degrees. So this would be our opposite. This would be our adjacent. Okay, we don't have a lot here. So what would be the very first thing that you would do? Well, you can figure out this angle real easy, because if this is a 90-degree angle, this is 37. This is what's going to be left over from 180. So angle BCA is 180 degrees, okay, minus 90 degrees, minus 37 degrees. If you throw that in a calculator, you get 53. Okay, so now we already know that this is 53 degrees. We're halfway there. We've got this angle, 53 degrees. Now let's figure out side AB. Side AB, we would use cos of 37 degrees, okay, equals AB over 33. All right, if we want to isolate AB, we multiply both sides by 33. So that means that AB equals 33 cos 37 degrees. Okay, throw that in a calculator. That equals 26. So AB equals 26. Now I don't think we have any units here, so we just call it 26. Well, now we have to figure out BC, this opposite here. Okay, so in this case we use sine 37 degrees. Now do you know why we do sine 37 degrees? Because we've got this opposite here. So sine equals opposite over hypotenuse. We're going to use the hypotenuse of 33. We got our BC up here. We got our 33 down here. So BC equals 33 sine 37 degrees. Okay, throw that in a calculator. You got 20. Now we've figured out the opposite is 20, and that is angle BC is 20. We know that AC is 33. We figured out AB is 26. We have solved the right triangle. Why don't you give this one a go, solving DEF. Find all the angles and all the sides. Give her. All right, we're back. Well, we can do the same thing that we have done in the past. We're going to figure out little parts of this until we've got the whole thing figured out. Hey, we've got kind of an a squared plus b squared. We can figure this out using Pythagoras. So df squared equals 4.9 squared plus 5.3 squared. All right, so we'll throw it into a calculator. 4.9 squared plus 5.3 squared equals 52.1. Okay, so df squared equals 52.1. So we want to root both sides. Let's take this and root that. That is 7.21. So df equals 7.2. So we can put that right in here, 7.2. And we're halfway there. we have all of our sides. Now let's figure out some angles. Okay, let's do tan. We could start anywhere, but we're going to go tan F. And look at F here. All right, so if we're going to do tan, we've got our opposite over the adjacent. So that would be 5.3 over 4.9. Okay, put that in the calculator. 5.3 over 4.9 equals, and then we inverse and we hit our tan, and that equals 47 degrees. Okay, so tan F degrees equals 47 degrees. We have this now. Okay, and that is DFE, always looking for the center one. Okay, angle F. So EFD equals 47 degrees. Well, now that we have that, let's take a look at angle D. So we look at angle D here, and we know that this is 90. All right, this is 47. So all we have to do is add all of this up to 180, or this plus this equals 90. Well, this is really close to 45. It's a little bit more, so this is going to be really close to 45, but it's going to be a little bit less. It's going to be 43 degrees. So that is the one that has the D in the center is 43 degrees. We know that DEF is 90 degrees, and we are done. All right. So I hope you've enjoyed this. You did a great job. We'll see you in the next lesson.